Hello, everyone. Welcome. Good morning, good afternoon, good evening, wherever you are watching from. Let's talk about what's new in PyScript 2023.05.1, which I'll probably call 23.5.1 from now on, just for brevity's sake. Yeah, we're just going to dive right into it. If you are watching live on YouTube right now, welcome. Please feel free to ask questions as we go along. I will talk about the things that are new and that I'm most excited about, but if you have questions about those things or others, feel free to drop them in the chat. I see we have one question in there already about micropython and packages, which I think we will answer incidentally when we talk about using Xterm.js in the browser. If you're watching later on YouTube, there are timestamps in the video description down below, wherever it is on your YouTube player, that'll let you skip to the various points in this presentation that tell you the things you're interested in knowing about. As we dive in, here I can show you just briefly what we're going to be talking about today before we get to it. We're going to run through this real quick, and then this is the things we're going to talk about. So let's see here. We get my little slide thing on the bottom of the screen there to advance. Let me see, because that is a useful feature, I think, for folks who are skipping through the video. You'll see a little bit behind the scenes here when I just start to try and configure that. And if it crashes, which it looks like it has, then we'll just get rid of it. And it's going to be great. So the things we're going to be talking about today are the new script type Py attribute in addition to the PyScript tag, the new Python when decorator for hooking up event listeners from within Python. Marcelo, hello, good morning, good afternoon, I guess, where you are. The new, some improvements to the Py event HTML attribute syntax, also for event hookup. A couple little details just to close out, like PyScript overall behavior, about how we import Pyodide and how we're logging things to the console. We're going to talk about the PyRepl today. It has gotten a lot more powerful in the recent release, which I'm excited to talk to you about, some new attributes and some new plugin methods that we'll see here. We'll talk about some improvements to the PyTerminal, which is how we output sort of text to the browser window, and some cool new options there and behaviors. We'll touch briefly on Pyodide OTOT 23.2, which is the version of the Pyodide Python runtime that we are bundling into PyScript now, which is very cool, and some cool improvements that come along with both the upgraded Pyodide version and the fact that it's now running Python 3.11 instead of 3.10, so there's some cool upgrades that just come along with that for free, which is awesome. I'll preview PyScript.recipes, which is a new website that I am putting together, or have put together, for illustrating key points in PyScript and Pyodide. We've got a new team member I want to talk about, and then I really want to talk to you about what's next in PyScript. And these two things are related. Andrea has been really blazing a trail toward a new sort of foundation for how we're running PyScript in the browser, including a cool technical preview that I will get to show this to you live. It's not a fully featured demo or release or anything. This is just like a peek behind the scenes at what's coming next, but it is runnable in the browser, so I'd be ashamed to not actually share that with you and talk about it. But we will get to that in just a little bit here. Oh, good morning. Yes, Henrik, thank you so much. I'm glad these are useful. I hope they are helpful. And like I say, I think they'll be most helpful. Oh, that's the chat. You don't need to see that. I think they're most helpful if you ask questions, or if you say, hey, Jeff, you went too fast there. That doesn't actually make sense. Can you slow down just a little bit? And I would be more than happy to. The one thing I want to clean up here, just because I think it's going to make everybody crazy, is as you can tell, the standby on the bottom of my screen is locked into standby mode. And it seems to have crashed, and it's not really doing the thing. So I am just going to get rid of that for today, and we'll see if that persists. It probably will pop back up at some points, but that's all right. Well, we can survive. You just have to listen to the sound of my voice, and like I say, if you're watching this later, you can click on the timestamps in the video description to jump to what we're seeing at each point. Yeah, shall we just dive into what's new in PyScript? I think we should. Okay, so let me see. You can see my screen. The other thing you should tell me, if the font size is wrong, right? I have a giant monitor. You may be watching on your tiny phone. If that's not the right size for you, let me know. We'll blow it up. We'll shrink it down. It'll be great. Okay. First thing on the agenda, script type Py. Okay, so let's look at what we're doing here. Let me blow up my code sample here. So this is what a very basic PyScript web page looks like, right? We have a head section, which has a title. It has our link to PyScript, the JS module that is PyScript. Script defer source equals https://pyscript.net/releases/2023-05.1/pyscript.js, which is our latest release that we're talking about today. In a lot of early examples, you might see something like alpha or latest. Alpha is a very early release. You should update to something newer. Latest is always linked to the most recent release, which is very convenient. I know why people use it, but if you were linking to /latest in your code, a couple days ago, we broke your code for you. So I always recommend linking to a specific release of PyScript. In this case, /releases/2023-05.1. That means that when your code is broken, it's on you and not on us, because we will introduce breaking changes with every release. That's just something to be aware of. Similarly, I've linked in our PyScript style sheet here. Same URL, just pyscript.css. This does very little. It does a little styling around the repl tags, around the PyScript tags. You don't necessarily need this, but it will clean up your presentation just a little. Okay. So in our basic PyScript page, our very basicest PyScript app, includes a py-script tag. That's sort of like the core of PyScript, right? Is you put a PyScript tag on your page, and when you do, you get... this chat is going to keep popping up on me, apparently. You get Python running in the browser, right? So I have a print statement, which shows up in our PyTerminal down here. I have a display statement, which is our syntax for inserting text into the web page. And that shows up sort of in the DOM, in the page there, as hello world. Let's just clear up which one of these is which. I'll just do a resave and a reload, and we'll see, display sort of shows up in the page, PyTerminal shows up in a terminal, vaguely speaking. So this all is well and good. This works, thank goodness. That's what we've been doing in PyScript for a year. We are doing some little crimes to make this work. So this py-script tag is what's called in the web parlance a custom element. Not that long ago in web time, there was added to JavaScript the ability to say, hey, I would like to define a custom tag like py-script that has some custom behavior. Maybe it wants to have some behavior when it is inserted into the page or removed from the page or something like that. And this is all well and good, except that these custom tags are treated just like any other page tag in that they are parsed. Now, what do I mean by parsed? So I know we have a lot of folks who are from the Python side and not the website, so let me just explain real quick. When you have the elements on an HTML page, like a div, which is a wrapper, or a paragraph, when the page loads, your browser goes through and basically parses this as a tree of tags. It says, okay, I'm reading in, I see I have a body. Okay, we're now inside this body tag. I might have some more text. That's just plain text. Oh, I see I'm going to have a container, a div tag. Okay, so I'm going to start in my mind a new subcontainer within body. You can see actually if I hover over it in VS Code here, it's saying the div element has no special meaning. It represents all its children. It's just a container. Okay, in that I have a paragraph tag and so on. It's constructing a nested tree of these tag elements on your page as the page loads, right? And then it's able to do things like, okay, well, everything inside this div should be treated differently or uniquely or something like that. We're able to sort of parse the page in a structured way. Unfortunately, it's doing the same thing inside our PyScript tag, and that can lead to errors. Let me show you how. Let me get rid of a couple of these. And if I want to say, in my PyScript app, let's talk about the p tag, right? If I save that and load it, what I think I will see is nothing good happens. If I open up my console here, oh, goodness gracious, I have a huge error. You probably can't read super well. Let me blow that up a little bit. It's got a big old error. What's happening here, if I scroll up to where it's actually doing the parsing, you actually see the parse error that it's experiencing is actually at a comment that follows the PyScript tag, which is weird. If we look at our page elements, we can see that that comment is hiding somewhere down here. Yes. Let's see. It's maybe a little hard to find. So it's complicated by the fact that I'm running a live server to show you these demos. But essentially what is happening here, let's see, let me come back to console, is that I'm getting an invalid syntax error, which obviously is bad. And why is that? Well, as Python is parsing, or as the browser is parsing through my tags, it says, okay, I'll open a new tag called PyScript. I don't know what that is yet, but presumably the user will tell me later what PyScript tag means. We'll just say open a PyScript tag, and they'll tell me later what the behavior should be. Okay, it's got some text. I don't know anything about text. We should be starting a new paragraph tag. Great. So what's inside of here is not, in fact, in my PyScript tag. It's in a paragraph tag and should be treated separately. And so from the browser's point of view, our PyScript tag contains just that. And everything after it is inside a new tag, a paragraph tag inside of our script tag, and is unavailable to our PyScript tag to be parsed as code. That's the gist of it, is that once we have something inside of our PyScript tag that looks like another HTML tag, the parsing of our PyScript tag stops and something else starts happening inside of it. Which is a shame, because of course we just want this all to be treated sort of as raw text, if you will, to be parsed later by our Python interpreter. So what's the solution here? Well, there is one tag that all browsers treat as special, as different, and that is the script tag, the OG script tag, if you will, that inspired the PyScript tag. The script tag is for usually running JavaScript in the browser. So this is not going to work very well either. If I run this code, I suspect bad things will happen. Oh, yeah, so what's happening is in JavaScript, the print statement is actually for printing your window to like a physical paper printer. So now I've run print, and it's like, I guess you wanted to print your blank web page? That's bizarre. So this is obviously not what we want either. But PyScript 2351 adds the ability to make this a script type Py. And now if I reload the page to get rid of that print dialog, what we'll see is we get down here the original text we wanted. Let's talk about the P tag. Essentially what we have done is made script type Py, or for that matter, script type PyScript, if that feels better, an alias for the PyScript tag. So script type Py, script type PyScript are exactly the same as a PyScript tag. The difference is, and the advantage of adding this capability in, is that when the browser sees a script tag, it doesn't try to parse the internals as HTML. It says, okay, well, this is some code that I really shouldn't touch. Let's just skip down to the end of the script tag and continue parsing from here. And that allows us to do things like put things that look like other HTML tags directly into our code without making things throw up. For all other intents and purposes in PyScript, PyScript tag and a script type Py tag are identical, right? They are literally alias to each other inside the code base. So if everything's working fine for you using a PyScript tag, continue with that, no worries. But if you are, especially if you're writing a page that talks about HTML tags, or you're using PyScript to talk about the browser, or we've even seen some errors pop up when we have things that look like tags that people are doing like with a greater than or less than symbol. I'm not sure I'm going to be able to like come up with an example of that on the fly, but if I have an f string say 1 is less than 2 is greater than 3. We'll see. I don't know if 2 is a valid HTML tag. We'll see if this crashes. Is false. Okay, so that evaluated successfully because 2 is not a tag. I don't think quotes. I think quotes will self-escape it too. We've seen some really odd edge cases where people have been doing like string comparisons or object comparisons using greater than or less than, and that can cause things to go sideways in terms of the same parsing as well. Oh, I guess I'm in a script type Py. Let's see if this throws up in a PyScript tag. So all this to say, if you've been happily using PyScript tags from the beginning and it works for you, great. If it has been crashing in this way, which it looks like, if I'm reading this right over here, it is in this particular weird comparison case, right? I don't know why your code looks like this, but if it does, using a script type Py tag will solve your issue. Make sense? Super cool. That will continue to be the same into the future. We're just going to alias those two things together. The other thing you may get out of this, we have lots of folks who are interested in using PyScript inside of a dynamic framework like React or Vue or something like that. And those frameworks treat a script tag in special ways because they know it shouldn't be parsed or necessarily associated with the virtual DOM or things like that, in a way that a custom element like a PyScript tag is just another tag that they are happy to munge on its way to the browser. If you are working with PyScript in a dynamic framework and you're having these kinds of parsing and placement issues, try script type Py and see what happens. And we would love to hear from you as you experiment. Cool? That's script type Py. Let's carry on. The next thing let's talk about is the @when decorator. So The when decorator is a new piece of the Python API for PyScript. So this is just a new thing you can stick into your Python code to do useful things in the browser. It is in the PyScript namespace. From PyScript, we'll import when. And that'll bring in our when decorator. And here's how the when decorator works. Let me give first some element on the page that we can use to emit events, like a button. We'll give it a button. We'll give it an ID of button. For those who are not used to web dev, an ID on your HTML page should be unique. This is a way that we're going to grab elements from the page. And I will say, click me. It'll be the text in my button. And when I load that, I should see, yeah, that click me button that pops up on my screen there. Here, I can probably hide the interpreter for now, just to clean things up. So let's say what I want to do is when I click this button, I want to have it, I don't know, print hello world again, just something really simple. We have a new way of setting that up directly within our Python code. So in my Python code here, inside my PyScript tag, let's write that function first. We'll call it say hello. And inside we'll say print hello world. You could use much more advanced things here, but that's good enough to be getting on with, right? So what I'd like to do is sort of hook up this say hello function to my click me button. So when I click the button, I run this say hello function. And here's how that's going to work with the when decorator. I will say at when, we'll decorate this function. When takes two parameters. The first one is the name of an event type to respond to. And the second is a CSS selector of what elements on the page to apply it to. So let's break down both of those things. The name of the event type, so in JavaScript, in the web API, if you will, there are a ton of different events that you can respond to that are emitted basically on any user interaction, and honestly a lot more things that happen in the browser. Things like click, things like mouse over, things like script finished running, video playback advanced, video playback done, things like this. And there's a huge list of them. If you look at the JavaScript events reference, which is linked in the blog post in the video description, you can see the entire list of events that you could be reacting to. So we'll specify one of them here that we're going to respond to. And then we're going to use a CSS selector to say which events in the browser, which of the browser elements on the page we're going to hook up this function to. So CSS selectors, again, for those who are coming from Python and not the web, CSS selectors are a really powerful way of describing what elements on the page we want to be talking about. There's a slightly special syntax which you will very quickly get used to. God, I almost said this hashtag, this pound sign, I guess, as we would have called it before 10 years ago, says look for the ID of an element on the page and grab it. So a pound sign and BTN grabs the element with the ID of BTN. There are lots more ways that you can grab things on the page using this syntax. Just to share a couple because I think they're interesting and powerful. Let's add a paragraph with a class of foo, and a paragraph with another paragraph with a class of foo. And if we wanted to grab both of those paragraphs, I could say dot foo. Dot is the notation for grab the class with this name. There's a nested selector, which I'll show you in a second. There's ways of saying, grab every element that is a child of this that is not the class of that, things like that. There's a very useful and concise nested syntax, which we'll get into maybe in just a second here. But for now, we'll just grab this one element with the ID of button, and we'll hook it up to the click element so that when I click it, I see hello world. So by decorating this function with the click event, and we've grabbed the element with the ID of button, whenever we see this event on these elements, we run the function decorated below. So if I click this button, I get click me in my PyTerminal, right? That's the gist of it. When you see this event on these elements, run this function. That's all it is. Where this starts to get powerful is when you start utilizing some of these CSS selectors. Let me show you a couple ways where that could happen. Let's say I had a very basic calculator program. So we'll put in 3 buttons with 1, 2, and 3. And I would like to say, when any of these buttons gets pressed, print hello world. I guess it's not a very good calculator, but again, we'll get there. Another thing I can do with the CSS selector is select objects by their class. I can say, hey, grab all buttons and hook up this event listener to them. So now, whenever I click any of these buttons, I should see hello world, right? So an easier way to grab lots of things. I can also do a nested selector. So if I wrap these in a div in one of our containers, and maybe I give that the ID of calculator, what I can say is grab the calculator and then grab all buttons inside of it and hook those up to hello world. Maybe I'll add an additional button out here that is not inside of our calculator just to show that off. So now I should see hello world, hello for 1, 2, 3, but not 4. So this is the syntax when you just basically list things after each other. You say everything that's, you know, a child of this selector, which is also this selector. So every button that is inside of the element with the ID calculator should get this function. 1, 2, 3, but not 4. You can also, so you can start to see, like, you don't have to sort of connect one element to one function. You can, with the clever use of these CSS selectors, you can say, I'd like to apply this functionality to these specific elements based on my page structure, which can be really useful. You also can be even more powerful because you have access to the event object inside of your event handler if you want it. So what does that mean? Again, for those who are not familiar with event objects, the when decorator sets up, if you pass it a function with 0 arguments, it will just call it when it sees the appropriate event. If it is a function or callable with 1 argument, it will be passed an event object from JavaScript. I actually don't know what its string representation is. I think it'll just be like pointer event. Yeah, so you can tell when we're seeing this click event now on our buttons, we're being passed this event object from JavaScript, which is called, in this case, it's a pointer event. It's a thing it got from my mouse. I think if you were running this on a phone, if you touched it, you get a touch event, which both are represented by click and things like that. So what is this event object and what does it do? Well, let me show you. It'll be easier if I actually log this to the JavaScript console. It'll print out a little bit nicely. We'll say console.log event whenever we see it. I'll open up my JavaScript console over here and shrink that a little. So now if I click this button, I get it to print out for me over here. Actually, I'll click it a few more times so it's above my little camera view there. We can see that this pointer event gets passed to our event handler. And this pointer event has so many useful attributes. So, and here we get things, it's a huge list of useful things. Things like, is the Alt key pressed by this click? Which buttons were used to do it? The X and Y coordinates on the element that was clicked when it was passed. Control key pressed. Or was the pointer moving at the time? One of the most useful, actually, is this target element, which is the element that threw the event, that bubbled the event in the first place. Threw is the wrong word, forgive me, webheads. That triggered the event in the first place. You basically get a reference to the thing that started the event, and we can use that to do some even more powerful things. So if I come back to our code here, and we don't need to log this anymore, if I say print event dot target, right, which is a reference to the element that threw it, dot inner text, which is literally just the text inside of that element. Now, when I click my 1, 2, 3 buttons, I should see 1, 2, and 3. So even though we're only decorating one function, we can start to have really disparate behavior because we can read the properties of the element that triggered the event. Does that make sense? So grabbing event.target is a really powerful way to start adding additional functionality to this. And of course, our for button doesn't do anything. We didn't hook it up to the event because it doesn't match our CSS selector. You can use the when decorator multiple times on the same function. So if I say at when mouse over, how about, what's our selector going to be here? How about just the calculator container as a whole, calculator selector as a whole? Now, so you can see when I bring my mouse up here to start hovering over the container that has 1, 2, 3 in it, it's basically every time I hover over the container, it reads out the inner text of that container, which in this case is 1, 2, 3, and prints that out to the screen. That's in addition to me being able to sort of click 1, 2, 3 and get those outputs out, which is pretty cool. So you can, if you need to hook up the same function to multiple selections, so let's say I wanted to have a div ID equals other button, I could just say on click hashtag other button, and have the same exact behavior for some other element on my page, right? So now the for button is hooked up to our function via this click other button statement, and 1, 2, 3 were hooked up because of the @when click calculator button, if that sort of makes sense. Yeah, so you can tell I'm very excited about this feature, and it's when you start to realize that you have lots of very specific ways of selecting elements on the page and lots of different events you can respond to. Makes it really easy to start creating complex behaviors with just sort of very simple syntax. Things that are not included that you may be wondering about, but that we are currently building into PyScript. There currently is no way to remove these event listeners once they're attached on the page. We're adding something like a remove when function. So say hello.remove when or something like that will be in the next version that allows you to remove listeners once they're enacted. The other thing, just to say out loud, is the function, how do we say this? The event handlers are hooked up exactly once when the when decorator executes. Right, so this when decorator is essentially a function that says, hook this up to these elements right now, and then it forgets about them. So that is all to say, if you had some code that was adding additional elements to the page after this decorator has run, even if they match this selector, they are not going to be affected by this decorator. Let's see, what's an easy way to show that? So let's see here. So let me simplify my example here a bit. We'll delete some of this. We'll just say each of these buttons gets hooked up. They will all print their inner text when this runs. So we should get 1, 2, 3, easy enough. If I then add an additional button to the page, I could say new button equals js.document.create element button, js dot document dot is it js.document.body dot append element append child, sorry, new button, and we'll say new button dot inner text equals 4. Let's see if I've gotten all that syntax right off the top of my head. I probably haven't. Oh, there we go. Hey, it worked. So what's happening here, and I'll blow this code up so you can see it all, is after I've decorated my function, I'm using some of the JS API to create a new button element behind the scenes. I'm setting its inner text to 4, its text content to 4, and then I'm slapping it onto the end of my HTML document after the fact. What I want to point out here is that even though this new button is a button, and therefore would match the CSS selector, because our when decorator already ran, we are not going to see the event happen on that button. So 1, 2, and 3, which were present when the when decorator executed, are hooked up to our event listener, but 4 is not. Does that make sense? When decorator runs once, and then it's done. It's not sort of a dynamic real-time adjustment. That is the basics of the when decorator. Are there any questions in the chat? I need 10 seconds for water, so feel free to ask questions as you go, and I will look at the chat while you do. I see a question from Marcelo in the chat. I think it was from a little bit ago. Yeah, Jeff, is there already a library to import my Firebase credentials and interact with a real-time Firebase domain? So, the short answer is no. There's not currently. And the trick there is not so much that it's impossible or hard. The trick there is that PyScript is, if you're talking specifically within PyScript and not in Python, PyScript is a front-end web library, right? All the premise of PyScript and Pyodide is it's running code directly in the user's browser window. So we ship the whole CPython interpreter to the browser and let all the code run there. And like any other front-end process, that means that all of the information that's relevant lives in the user's browser window, has to live in the browser window sort of by default, because that's where the process is happening. And so in order to have a library or a package or something that was taking your credentials and validating them against like Firebase in your case, you would need to ship your credentials to the user's browser, and that's bad. This is a place where you would want to have a little bit of backend infrastructure that was handling that authorization and those requests and forwarding them essentially from your server, which is running this authorization. Could be a server, could be a serverless function like a Lambda or something, which is, just a server that you don't have to configure, that's doing that validation in a place where your credentials are secure, and then passing that authorization off to the user's browser window in some way. And that is true of any front-end process, right? If you're building a front-end in Vue, right? Vue's maybe a bad example because they have front-end and back-end components as well. But if you're doing something purely in the front-end with like Alpine, there's no way of passing those credentials over while they're still secure, because sort of by definition, everything has to live in the user's browser window. So you need a little bit of back in there to take care of back-end-y stuff, is the gist. But good question. It's a question we see a lot. It's like, can I do everything in PyScript? Can I do it all from the user's end? And the answer is, if you want it to be secure, not quite. But that's just how the web works, essentially. All right, what is next? Oh, okay, this is a related topic. Let's talk a little bit about the PyEvent syntax. Let's minimize this here for now. And let's get rid of some of our buttons. So the PyEvent syntax, which some of you may have used before and some of you may have not, looks like this. To any HTML element in the page, we can add an attribute that looks like py-the name of some event. This is the same event names that we were just talking about in our when decorator from the big list of names that the browser allows you to have events called. So it could be something like pyclick, or PyMouseOver, or something like that. I often use pyclick in the examples just because it's really easy to interact with, but again, this could be any event name that our element is going to emit. If I have an attribute on an HTML element called py-the name of some event, and its value is equal to some string of executable Python code, that code will be run when that event happens on that element. So I could say pyclick equals print hi. And now when I click on, I have my for button here. Oh, I still have my code. I was like, what is that for doing there? I still have my code that's adding that for button as it runs. That's hilarious. But now when I have this button that says pyclick equals print hi, every time I click it, I should say hi. What is happening? Oh, I have my when decorator still active too. Let's get rid of a bunch of this. Let's get rid of the when decorator. I'm going to save this for a first and a second, but I want to just talk about PyEvents for now. I was like, wow, I'm losing my mind. So pyclick, right? So the gist of this is when this HTML element emits the click event, we execute this string of Python code. So I click this, I say hi, say hi, say hi, say hi. This could be, this is an executable string that runs in the main Python namespace, in the global namespace. So if we have predefined another function, like say bye, and it says print goodbye, then I can reference that function in my PyEvent attribute. Basically, we're executing literally at at a low level, calling exec on this string of Python code whenever we see this event. So now I can see say hi. The say hi button now says goodbye, which is not so good. Because we're calling exec, I can also make this a multi-expression statement. I could say from JS import console. Let's make this a little bigger. Console.log. Wow. Right, and by putting the semicolon in there, this is now a multi-expression sort of statement. And if I open my JavaScript console here now, when I click my button, I should see wow pop up in the corner there. You can see that behind me, yeah? So we don't have to have just one expression or statement here. This can be multiple expressions because we're calling it with exec. That is just a refresher on the PyEvent syntax. And again, this can be any named JavaScript event. It could be PyMouseOver. So now whenever I mouse over this button, I should get wow in the console. Boop, 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 boop. Great. The change, to come back to what's new in PyScript 23.5, is that these are now dynamically updated. So in previous versions of PyScript, these PyEvent attributes would be parsed basically one time at page load. Their event listeners hooked up, And that was it. That was all that was happening. Now they are updated each time that this attribute changes. So let's demonstrate that. Let's change this back to a simpler example. We'll say pyclick equals print height. So when the page loads, I should be able to click this and say height. But now, if some piece of code changes this attribute, we should see those changes update in real time. Actually, yeah. So let us do something like my button equals js.document.get element by ID button, and we'll just give this an ID of button. And I can say button dot, I believe it's set attribute is the thing we'll have to use. Normally you could do something like button dot, source or whatever, some attribute, but because the attribute has a dash in it, and dashes aren't allowed at attribute names, we have to use this set attribute function, pyclick, and we'll set that to print by. We'll see if it's thrown up on me. I may have to pull up some documentation to remind myself if I think set attribute is correct. So now, after my code has run, what I should see is that because I've changed the value of pyclick to be this new Python statement, now when I click say hi, it says bye. So all this is just to point out that these attributes are hooked up in real time anytime they change. They are also hooked up in real time anytime you add or subtract new elements to the page, right? So again, instead of being parsed once when the page loads, they're parsed whenever the page changes. So if we were to use our PyScript code to add a new button to the page, that button will also have its Py events responding correctly. So let's do that. We'll say button equals js.document.createElement button. We'll say button.setAttribute pyclick print something like I'm new. But I'll leave the apostrophe out because I realize my quotations are getting a little complicated. And js.document.body.append child button. I should probably put some text in there as well, just so we can see it. Button.innerText equals new button. All right, so after this code runs, we'll create a new button on the page. We will set its pyclick attribute to this new print statement. We'll give it some new text, it says new button, and we'll throw it on the end of our HTML document, pretty casually there. We can see that button did appear once our code had run, and now when I click it, we should see I'm new, which is the pyclick attribute of this new button. So basically, whenever you change, adjust, add, remove your py-event syntax, it will now be updated in real time and functional on your page. You no longer have this restriction that we had before where it was parsed once when the page loaded and then never again. That's thrown out the window thanks to some nifty things happening under the hood in JavaScript. This is now updated in real time whenever you change it, which is really, again, handy for dynamic user interfaces and event listening. So that's the Py event syntax updates. One little thing to mention there as well. In previous versions of PyScript, we basically had a hard-coded list of the events you could use in this context. It was like 40 different of the most common events, but we literally listed them by hand. And now there's been some adjustments under the hood where this can be any event that the browser recognizes. We're not even hard listing them. We're basically saying when we have an attribute that looks like py-click, try and do something with, and if you see an event that looks like this, do something with it, right? This could be py.orange, and if an event called orange ever happened on this button, it would run this code, right? So it's much more flexible now. Awesome. So that is the updates to the Py event syntax. Let's touch really briefly on a couple of more little changes to like the PyScript lifecycle and tag, and then I want to talk to you about updates to the REPL because they're really, really cool. It's two little tiny things. And I would just talk to you in face about them because there's nothing to show on the screen. They just have to do with the internals of PyScript and Pyodide, which is the C Python interpreter that we're using. One is we are no longer printing the message Python initialization complete to the terminal log. That's something that Pyodide used to do. When Pyodide finished loading, it would put in this log on the console that said Python initialization complete, and we were using that for some signaling. That went away in a previous version of Pyodide, but we put it back in because we knew some users were going to be relying on the presence of that console message to signal that some things were happening. We've taken that out as well. So all this to say, if you are looking for the specific console log Python initialization complete to signal that PyScript had finished loading, you'll have to do something else now. And we do have better ways, but that specific one is gone. The other is PyScript used to load Pyodide by slapping a script tag on a page. Basically we were doing, when we wanted to load Pyodide, we were doing something like, literally like inserting into the head, script source equals, some cdn, dsdeliver.com/py. Like we literally were slapping a script tag into the page, which works fine. That's a perfectly valid strategy. But now we're importing it under the hood so we can interact with it in a smarter way. So again, if you were looking for the presence of the Pyodide script tag on your page as some kind of signal as what's happening in PyScript, again, that was an internal implementation detail. That's gone as well. But again, we have better ways of detecting these things now. So just know that if we broke your code, we're sorry. There's ways to make it better. Okay, that's two little things out of the way. Let's talk about the REPL. So for those who may not have seen it before, PyScript includes a REPL. And bring that up here. Close my interpreter. We'll see if this works okay with my dark background. It's not great, honestly. I probably should have adjusted this before. Let's take out we'll take out my custom styling, just so we can see this. I apologize for the dark side on one side and the light side on the other. I hope you'll forgive me. So if you have a py-repl, a PyREPL tag on your page, when the page loads, we add this little segment, which is a REPL, and it's user interactable. So here I can take out the internal contents and leave it blank. And now my user has an interactable REPL on their web page. To run it, I can either come over to the right-hand side and click on this arrow button, or I can hit, I think it's Shift-Enter. Yeah, we'll execute them both. And you can have multiples of these on your page. You can interact with them. A really easy way of dropping a real honest-to-goodness Python REPL whose code all runs in the user browser into your web page. Like, remember, there's no server backing this up. This is literally the CPython interpreter running inside the user's browser. In this case, the user is also me, but you get the point. We have added some cool new features to this REPL in Python 23.5.1. Let's take a look at them. One of the first of them is the source attribute. So PyScript tags have a source attribute, which is a URL to load contents from when the page loads. The PyREPL now also has a source attribute to load content from when the page loads. So if I make a new file, let's call it repl-demo.py. And inside that, I put some text. This is some other file. Now, if I come into my PyREPL and I say source equals repl-demo.py, then when the page loads, I should see the content of that other file being preloaded into my REPL for my user. Right. This is a much requested feature, and we're happy to have it. Basically, we have lots of users who are interested in using PyScript to create like a Python tutor or teaching service, or hey, run this code in your REPL, and we'll evaluate it and see if you wrote it correctly, that kind of thing. So this is an easy way to say, hey, if you have that content that you want to preload for your user in a separate file or add a separate URL, you can use this source attribute to preload it here. You can also what's going to be a good way to show this? Anytime this source attribute changes, the code will be reloaded. So how to show that, I wonder. Let's see here. Let's add a PyScript tag. Let's do it in PyScript because we can run code in the browser. So give this an ID just to make it easier to grab. And what I want to do is this. Basically, I'm going to have this page load with some demo content, and then I'm going to have a button that loads it with some other content. And that button's going to represent, maybe some other state on your page that's changing. Maybe you're loading the next quiz for your user or whatever you're doing with a REPL. I'll show you how this is going to work. So I'll say import JS to grab the JS namespace. I'll say REPL equals js.document.getElementById REPL. And I will say REPL.source equals new code.py, which we'll write in a second here. I want this to happen on a button press. So let's add a button to our page. Button. I will say, let's see. Let's make this all into a function. We'll say set new code is going to do that little adjustment where it sets the source attribute of our REPL to this new value. And then in my button, which I will label with set new code, I will add the PyClick attribute you were just talking about and say, when I click that button, set new code should run. This is a demo I'm making up on the spot, so we'll see if it actually works, but I think it should. Oh, I also am going to have to add this new code.py file. Let's do that really quick. Make a new file, call it new code.py, and then it will say, this is, here, we can even comment it. This is some other code that you might want to load on your page. So with that in place, let us see if this works. So my page loaded. It preloaded the code from repldemo.py. Now, when I click on my button, it should run this set new code function. And when that runs, I should grab the REPL element and set its source element to new code.py. Let's see if that works. Yeah, good. I love it when a live demo works. So what happened there is we changed the source attribute of the PyREPL itself to this new code.py value. PyScript responded and said, oh, I see you changed the source attribute. I, at this time, am going to load the contents of the file at this URL and put it into your REPL. And that could happen at any time, right? I could have been writing in the REPL, and then when I called set new code, again, oops. Oh, it didn't work. Oh, interesting. Ah, okay, interesting. This might be an improvement we want to make. So because the REPL in this case, its source attribute is already set to new code.py, resetting it to new code.py doesn't do anything. If I reload the page and my source is now repldemo.py, and I type into my REPL, and then, the user's been typing something, right? It's all good. And I hit set new code. Oh. Ooh, that's wrong. Ooh, there's a bug. Okay, well, cool. Well, bug report going up. The premise of this function, of this new functionality, is that when you change the source attribute, it should load the code into your REPL here. Clearly, something's broken. This is great. This is why I do these demos, and this is why I like doing them live, because you and I get to learn things together. Anyway, look for an issue going up on GitHub soon. This is the premise of this issue. It seems to work fine if the user is not interacting yet. If it does, we have a bug. Cool. Other things you can do with the REPL that I am confident work a little bit more cleanly. I hope. I guess we'll find out. We have added a couple of other new attributes to the REPL. So let's get rid of the source attribute here. So you may have noticed a couple of things happening when I was typing and executing the REPL earlier. If I do something like print foo and I run that, I get foo appearing down here in my PyTerminal, sort of our default text output, and I get foo underneath my REPL cell. And this leads to a kind of notebook-like behavior, right? If you're used to Jupyter Notebooks or something, you're used to the output appearing immediately underneath your executable cell. This also kind of feels like what happens in your terminal when you're running a REPL, right? You run your code here, the output appears right underneath your code below it, right? That feels kind of right, especially if we add the auto generate attribute to a REPL, which has existed for a while. Then when I execute my REPL cell, it puts the output directly under it and adds another REPL cell immediately below that, right? And now this really does start to feel a little closer to, what you're doing in a terminal, right? I have this command that I'm executing, then I see my output, then it puts my cursor down below that, and I can execute it again, and so on. So this is all well and good for most use cases, but we had a number of users, honestly myself included, who were like, this is for most purposes a fine place to put the output, but what if, again, I wanted to have something like a page that the user has a REPL, and when they execute it, I want the text not to appear immediately underneath it. I want it to appear in some special box, right, where my chatbot's going to say, you did a great job, or maybe you should fix this, or that, or I want to do something special with that output that gives you more flexibility than, say, just put it under my REPL. And that's what some of our new attributes are designed to do. So let's give ourselves a place to put the output from our REPL here. So I'm going to add a new div, again, just a container with the ID of out, and just to make it a little bit clearer what's happening, I'm going to give it a background color of aqua, which I know is wrapping off the screen there. But it's going to create a container with a blue background just so when things show up in it, we can see that they're really there. And now if I make the output attribute of my PyREPL out, what should happen here is that when I do something that involves standard out, like when I'm printing or whatever, the output is appearing not immediately underneath the REPL, but in the element in the DOM with the matching ID of my output attribute. So to say that again, when this REPL is outputting, it's writing to sys.standardout, instead of going sort of by default just under the REPL, it's going to find the element on the page with this ID and put the output there instead. So I could say for I in range 10, print I, and I get, well, not very well formatted, but I get 0 through 9 sort of as we'd expect, right? So the output attribute is a way of placing the output from your REPL into a specific element in the DOM. Mojo Logic, don't hate me for this question. How far out is PyScript from fully supporting Micropython? Ooh, Mojo, this is a really good question. Let me get through my couple of other REPL attributes here, and then I'm happy to answer it. I want to keep this section tight together, and I'll put a note in to answer your question in just a few minutes here. It's a good one though. Our other REPL attributes that you might want to use, we have an output mode attribute, which by default, if you are outputting it here, I'll show you the behavior without that adjustment. If I have a REPL on my page and I say print foo, and then later I say print bar, you'll see that the output gets appended to that location on the page, right? And that's sort of what we'd expect from a REPL-like situation. If I use my output attribute, what I will see, foo, print bar, again, it's being appended. The output mode flag lets you adjust whether that's going to be appended or not appended, or clear, essentially, should this internal element be cleared or not when that REPL cell executes. So we have output mode. Now what's interesting is this should not be appending by default. This should be, I think, replacing by default. So perhaps I'm doing this a little bit wrong. But you can check out the output mode attribute equals append, or leave it blank to adjust whether this is being appended to or not. I'm going to skip that demo because I now have a question about whether that's actually doing what I think it's doing. So check out the documentation on output mode that I think I wrote. So hopefully that'll tell you a little bit more. And then one last thing that I want to talk about for PyREPLs, sorry, before we move on, is the new PyREPL plugin attributes. So for those who haven't seen them before, PyScript has a plugin system. And I will confess, we haven't done a super thorough job of documenting it, partly because it just keeps changing. We keep building on it, and we keep changing it in breaking ways. So it feels like a thing. It's like we don't necessarily want to advertise it super strongly because it's all going to get changed and broken in the next sort of continuing beta releases that we're doing. There is some documentation on it on docs.pyscript.net. There's a guide on creating plugins. Exactly what all the methods are is only marginally documented, but we're getting there, and it is slowly crystallizing toward an actual public API. The gist of the plugins API, for those who might not have seen it before, is let me open up a demo file, and I can show you what that looks like. So a quick refresher on how plugins work, and then we'll talk about how the new PyREPL plugins work, and then Mojo, I will answer your question, is like so. If we have in our pyconfig tag an attribute called plugins, that plugins tag, plugins attribute, takes a list of URLs to load plugins from. Plugins can be written in Python or in JavaScript, and they look a little bit different, but essentially they do the same thing. So I wrote a couple of plugins in advance that I can show you. Let's see, pyplugin.py. I'll show you this one, and then we'll load it up. This is the general shape of a Python plugin in PyScript. We, from PyScript, import the plugin class, it's just a base class for plugins. We instantiate a new class to do what we want it to do. And if this class implements any of the named plugin methods, they will be executed at specific points in the PyScript lifecycle. So there are, I think, 4 lifecycle methods. And again, this is where our documentation is a little bit lacking, kind of deliberately, right, because it keeps changing. But we have a number of methods that essentially can be executed as PyScript loads. We have one that sort of executes right at the start when PyScript appears on the page, just before the interpreter is active, just after the interpreter is active, and things like that. So the gist of it is, if I have a plugin which has an after startup method, that basically is going to run whatever code is inside of it as soon as PyScript has completed all of its steps. So it's initialized the Python interpreter, it's hooked up all of our PyEvent listeners, it's done a little bit of cleanup in itself to clean up its internal namespace, and then it says run this code before we cede control back over to the user's page. Just as a real quick demo, if I add pyplugin.py to my pyconfig tag, what I should see is that at the very end of it, at the very end of PyScript execution, I see this is after startup, which is being triggered by the after startup method of my plugin that I just written. One thing to note here in this implementation, what's happening when PyScript loads this plugin.py file is it loads it and then basically into a module, and then it looks for an object named plugin, the literal name plugin, plugin, all lowercase, and it calls the methods of that object. So we do need to have this plugin, this basically an export statement, right, of plugin equals an instance of my plugin that we're going to call functions on as PyScript loads. That's the gist of the plugin's architecture. And you can see that after startup happens after everything else. If I add a PyScript tag, I say print hi, we'll see the PyScript tag executes all of its code, and then finally after everything is done, after startup will happen, right? So this is really designed not just for like printing things, but for doing advanced things that other users might want to integrate into their page, right? If you wanted to add a plugin that before the interpreter executes any user code, maybe you want to parse it and make sure they're not using async IO because you hate async IO or something like that. You could do that in a plugin using one of the tags that pre-parses, one of the plugin methods that pre-parses all of the user's content or something like that. This print statement is just sort of a stand-in. It's worth saying you can also write plugins in JavaScript. They have a slightly different structure. And in it, basically instead of exporting an object called plugin, JavaScript actually has an export syntax. You can say as you put a default export in your folder. You export default class, my JS plugin, and it will be calling the JavaScript methods again with the named methods as well. So if I add JS plugin.js to my list of plugins, what I should see is, let's see. Maybe not. JS plugin.js. I thought this. Oh, I tested this earlier. I hate this. Let's see. This is the essential shape of it. If I've goofed it up with a live demo, we do have documentation on this stuff at docs.pyscript.net that you should definitely check out. Now, why is this not? If I misnamed my after startup, gets a runtime, export default from JS. Let's see. Let's see if it's the Python plugin that's. Oh, I know what it is. I know what it is. This is logging to the console. This isn't supposed to be printing to the screen. This is logging to our JavaScript console. So if I open my JavaScript console, I should see, yes, this is after startup from JS is being logged after everything else happens. Phew! I thought I was losing my mind. So that's the gist of plugins. They run at various points in the PyScript lifecycle. Bringing it all the way back around to why you might care, there are now plugin methods associated with the REPL. So let's do this specifically in Python. We'll go back to pyplugin.here. So in addition to my sort of lifecycle events, I can add an event that corresponds to the REPL, like there are 2 new named methods. They are before pyrepl exec, and if I copy and paste from my other monitor here, after pyrepl exec. And I'll blow this up so we can see it a little bit better. Oops, there we go. So this is, here, we can get rid, the type hints there are going to be a little confused because I stole this right out of the PyScript code base. But essentially, oops, if I wrap this, we will see that we can add 2 new methods to our plugin module that will interact with the REPL in a cool new way. So we have this before PyREPL method and after PyREPL. They both get a copy or a reference to the Python interpreter, so we can do Python-y things with them. We get the user's source code as a string. We get the designated output element, so either the sort of the place in the DOM immediately under the REPL or that other place for output that we were looking at earlier, and a reference to the REPL tag itself that was doing the executing, right? And the after PyREPL method gets all those same arguments as well as the result of the REPL execution as a Python object, which is super powerful. So let's see some things we could do with this. Let me add to my before PyREPL just print the source. Before my REPL cell executes, just print out the user source to the page. Let's make sure this loads properly. Ooh, we have an error. Probably means I have a typo. Oh, it's all of my type hints it's throwing up about. Yeah, well, that's all right. We will just delete all of our type hints. Sorry, type hints. You gotta go. There you go. That's 1. And we'll delete this type hints. 2, 3, 4. You gotta go. Okay. That should be fine. It was failing to find those symbols as it was parsing through, but this should work just fine. Oh, I should probably add a PyREPL back to my page so we can see what we're doing. PyREPL. PyREPL is spelled like REPL. And so now I have a REPL on my page. And now if this has all worked, and again, this is a live demo. Yeah, Mojo Logic, this is how you know it's a live demo. I like to do these things live because we all learn things together. But if I say x equals 2, then when I execute that, what's happening there is it's actually printing to my terminal the x equals 2, the source code of my statement. Like I say, def foo print hi. And when I run this REPL cell, we are actually printing the source. We are receiving the source code into our plugin and printing it back out to the screen, right? And we could do much more advanced things than print this. We could say, you know, if await in source print no awaits, because we perhaps are doing some kind of demo where we don't want the user to be able to use coroutines or async await or something like that. So if I run my REPL and it has, oops, let's do, run my REPL with has no await and it runs fine. But if I add a comment with the text await in it, it should yell at me and say no awaits. We don't want to do that. Obviously, if you were doing this for real, you'd want to do something slightly more advanced. Maybe you'd be like parsing the Python into an abstract syntax tree and looking for async await, or something like that. But for the sake of an example, you can sort of see you get a copy of the user source code, and you can start to make decisions based on what you want your page to do based on that. We also, so, you know, doing things with the source is super powerful. Doing things with the output element you could also do, right? You could say outl.style.background color equals red. I haven't tried, this is a live demo, so we'll see if this actually works. But in theory, when this prints out, it should make ooh. Didn't run, which makes me think I probably have an error. Oops. Let's see, what is my error? Output element dot style. Interesting. What I think is happening here, so I was trying to grab the CSS style of this element directly, and I think I just have the wrong syntax for that, and I'm not going to bother to look it up now. This would take some more troubleshooting. But basically, you could grab a copy to the reference to like where the PyScript tag is actually supposed to be outputting and do some things with that or intercept it. The even more powerful thing to do is do something based on the results of the REPL execution. So in this after PyREPL tag, not only do you get the interpreter, the source that was just executed, where the output is going, the tag itself, you also get a copy. This is not the result as a string. This is the actual result being passed to you. So I could say something like, if result equals 2, print, or here, let's do something else slightly more interesting. If result mod 2 equals 0, we print the result was even. So if we run that, if we add that to our plugin and we say 2, we see printed in our PyRep, in our PyTerminal, the result was even. If I say 3, I don't see that printed. In fact, let's add an else statement. Else print not even. You know, this is obviously, again, a pretty quick and dirty demo. No even. 3, no even. 4, no even. This is going to throw up if I do something slightly more complicated, like it doesn't return. If it has a thing that's not operable by this mod operator, this is going to throw up. Like if I return a function, it's probably going to be a little bit sad under the hood. Yeah, my plugin is like, I don't know how to do a function mod 2. That's no good. So you'd want to do like some actual error handling and input validation here of like, if the result is an integer and integer mod 2, like you'd have to make this more functional. The point here is that because you get a copy of the results object, or really a reference to the result object, you can start to have a page that reacts based on the result of your user's REPL. All right, and this is the feature that that users have been asking for, is like, I want to make a page that has an interactive REPL, and I want to be able to tell if the user typed the right code, like wrote some, I told them to, on my quiz page, make some code that outputs an even number. I want to see if they did that correctly. This is the way you would do it. You'd write a plugin that has one of these, probably this after PyRepl exec method. You'd look at the results of the REPL execution, and then you could take some action based on that. Super powerful feature, super cool, and I'm excited to get it out into people's hands and see what they do with it. This was a quite a long explanation of the plugin tags. I know we took a long diversion into what a plugin is, so please forgive me. I just think it's a super powerful and cool feature, and I wanted to get it out there. I'm going to take a sip of water, look at other questions, and then Mojo, I know you had a question standing by as well, so give me 1 second. Just double check that we're unmuted, which is a classic mistake that I make. Let's see here. Mojo, your question was, let me remind myself, how far out is PyScript from fully supporting Micropython? Okay, so the answer I can give is this. There is a ton of work happening behind the scenes on Micropython. It turns out that getting Micropython to run in the browser, a relatively fast process. And also, none of this can I take credit for. This is all happening by much smarter people than me, including Hood from the Pyodide project, Andrea, who's one of our new team members I want to talk about in a bit, Damien over at Micropython. All these cool folks are working on making this happen. Getting Micropython to compile to WebAssembly and run in the browser, I believe, relatively straightforward. That's basically in the bag. With some adjustments and some APIs there. And when I say easy, when I say straightforward, I don't mean easy. I mean these are incredibly smart people following a path that I could never walk, that they were able to sort of make happen. One of the things that's happening alongside of bringing Micropython to the web is bringing Micropython to the web with the same foreign function interface that Pyodide has. So by that I mean, I've sort of tossed this around a few times in this video, that in PyScript and really in Pyodide, we can do things like, let me bring up our tag here. I can say, from JS import document, and that becomes a reference to the document object from the JavaScript global namespace, right? We're proxying JavaScript object into Python and back again. This is part of Pyodide's foreign function interface. They have an internal mechanism called Highwire, for what it's worth, that basically manages that translation and proxying of objects back and forth. And the work that's happening right now is to put that same interface into Micropython. So whether you're running this in Pyodide, the full CPython interpreter, or Micropython, you would still be able to bring objects to and from JavaScript inside that framework. And from my understanding, that is my understanding is this big on that whole front, but that's a more complicated process. But I know it is proceeding ahead at full speed, and then it's just trying to reconcile what does that mean? How does that work? How do the differences in CPython and Micropython mean that those two things work differently under the hood in a small way, in a laser way? What does that actually look like? So I know there's a lot of hard work happening on it on the PyScript team, both internally and externally. I know it's very exciting. There is a live and workable demo of it again, and I will see that in a little bit here. So when is it going to be available? How far out, which was your question? not for me to say. Unfortunately, all I know is that there's a ton of work happening. Everyone's very excited about it because, I mean, Micropython is just a much smaller interpreter, and so the load time is frankly incredible. And we'd love to see it on the web soon. I don't have, so that's kind of a dodgy answer just because it's not my answer to give. But it is very exciting. One of the things that we know is that, like, once you start to get to the load times of Micropython, the page load times, like actually like how fast is my page getting loaded over the wire, start to actually become more visible than the Python load time. Mojo says, will adding the Highwire type interface add much overhead? No, not in a really significant way. It's relatively lightweight. The loading, from my limited understanding, and if I'm wrong, there may be comments from the Pyodide developers down in the comments at some point. They can tell me exactly how wrong I am. To load Pyodide, which is, a megabyte and change, and then initialize the WebAssembly part of that program is partly what's taking a lot of the time. Micropython is a lot smaller of a load and a lot smaller of a WebAssembly binary, and so the load is just faster. Highwire doesn't add a ton of overhead loading time on top of that. It's very clever and very complicated, but I don't believe it impacts the load time in any, like, percentage-wise appreciable way. Fair question, but I think it is not something to be worried about. So I hope I know it's not a terribly satisfying answer, but it's sort of the best one I can give you for now. But Mojo's so excited for this. Yeah, me too. It's really cool. It's really fast. Yeah, it's gonna be awesome. Speaking of other cool things, he said, segueing with aplomb, one cool feature we've got in PyScript 2351 is a full terminal. Well, not a full terminal, at least a fully rendered terminal. So let's back up a step. In PyScript, the PyTerminal, our PyTerminal element, is a pretty rudimentary element, let's call it. So when I say print hello, and I print out down here, this element on the page, this black box down here, which we call the PyTerminal, there's really very little going on with it, and that's on purpose. If I come down and inspect it, we can see it's literally just a member of the pre class, which is HTML's way of saying pre-formatted text, uniformly spaced. Usually it gets a different font, right? It gets this sort of system-y font, and like don't do any additional styling to it. It's been formatted by the user, don't touch it. That's all the PyTerminal is. We create this pre-class and we dump text at it, right? It's supposed to be as lightweight as possible, get out of the user's way, not spend any additional time loading things. Great. That's great for a lot of applications, but sometimes you might want to do something that looks a little bit more like your IDE terminal, right? Where you have, a bunch of additional like coloring and formatting and additional possibilities to like lay out things on the page. And so what PyScript 2351 adds is the ability to use a more advanced terminal in the browser window. So let me jump over to my other demo code here. We have added another key to the pyconfig called xterm, which defaults to false. If you set xterm equals true, instead of just using a little dinky pre-tag as your terminal, we are loading what's called an xterm, which is a product by a project called xterm.js, which emulates the xterminal manager from like a Linuxy system entirely within JavaScript and entirely within the browser, right? So if I add a PyScript tag over here and I say print hello, right, we'll see that for basic text, it essentially looks the same as a PyTerminal, right? We print hello in this sort of monospace font. It looks basically the same. Where things start to get cool is that this responds to all the same terminal control codes as your X terminal normally would on your Linuxy system. So let's grab an example here that I wrote a little bit earlier. I'll make that a little bigger so we can see it. We'll just uncomment this. So let's make use of the term color package from Python. If you haven't used term color before, it's a really basic way of like making colorful output in a terminal, but it provides methods like, colored, which takes your text and puts some colors on it. Maybe I'll invert this one and make it blink and print it to the screen. If we were to do something like this in without our xterm.js, you will see that what it's actually outputting is hello world, and it's, printing a few iterations of hello world, and then a bunch of this gobbledygook that looks like nothing. And these are control characters that are meant to signal to the receiving terminal, hey, the following text should be in this color, on this background, placed at this specific location, this kind of Unicode character, and so on and so forth. The pre element doesn't know what the heck to do with that, but if we set xterm equals true, xterm.js does know what to do with that. So if I scroll back to the top of my terminal here, we now see we get full, rich, colorful output, just like you would in a native Linux terminal. So in this case, we had hello world red, but we reversed it, so it's black on red. We had green on red, we had red on cyan, and so on. We had sort of fully rich, colorful output directly into the browser window. Term color is like one of the simpler libraries that you can do this with, but if I comment that back out and bring in something like rich, the rich formatting library, we see that not only can we get like full color support, but if I print out their test card, we get so much more, right? So rich has support for colorful blocks and backgrounds, many different colors, doing table layout, Asian language support because it's got full Unicode support, tables and dates, pretty printing of errors. It has so much functionality that normally would only be available to you in your native terminal, but is now available directly in xterm.js directly within your browser window. This essentially we are not having to modify the Python libraries at all. If you have a Python library that's outputting rich text to a terminal, you can output it directly to the browser window through xterm, which is frankly super cool. You can get rich output into the browser. So why did we add this configuration term as opposed to making this the default? Well, loading xterm.js as a package is approximately 300 to 400 kilobytes of additional load, and we didn't want to put that on everybody. We wanted our developers to have the choice whether users would have to load that at page load time. So it's turned off by default, but if you want rich text in your terminal, you can do xterm equals true, and it will just be supported. It's worth noting, and this is in the documentation, that a lot of terminal coloring packages try to identify what kind of terminal they're in, because of course a Windows terminal and a Linux xterm and other historical flavor terminal all are a little different in this like what they expect to receive as their color signals. So a lot of the terminal programs, term color and rich being included, are trying to detect what operating system they're in or what terminal they're in, just so they can get the color right. In PyScript, we're not in an operating system, we're inside the browser window, so it's not uncommon to need to go in and basically force color rendering to be on. These two specific examples, like I say, are in the PyScript documentation, but for term color, you set this environment variable, force color to true, and that enables color rendering. In rich, you create a console with color system equals true color or 256, and that forces rich to say, okay, I couldn't detect that we were on, like, we're not on Windows 95, I don't know what we're doing. Oh, okay, I guess you just want me to output color, I will force that. So if you're doing, if you have another Python library that's doing rich output and it's not working, go in and see if it's doing any kind of color detection, because it will usually try and there'll be a way to override that, and you will probably have to, if that makes sense. So that's xterm.js. As an option in PyScript. The other option we have added is, you may have noticed actually, if you're used to previous versions of PyScript, that the terminal used to kind of like be somewhere located on your page, and now it floats. Now it's just down at the bottom of the page here. So you can see here, what if I print a bunch of stuff? If I fill up my page with content, I could even do this in a simpler way. I can say, put a big paragraph of text in. Oops, I created an error. What have I done? I've made a parameter that's unused. So if I add a bunch of text to my page, apologies for the flashing, you can see that my PyTerminal, when it pops up, floats at the bottom of my page, sort of docked to the bottom of my window. This is just an aesthetic change that we've made to the PyTerminal. Because the PyTerminal is meant for, like, behaving kind of like a terminal in an IDE, we figured that most users actually don't necessarily want it to be in a specific spot on the page. They want it to have a global sort of output attribute. So by default, the PyTerminal is now docked to the bottom of your page. the bottom of the window, I should say. If you want to restore the previous behavior, you can add this docked equals false parameter to your PyConfig, and that will make it an actual rendered element at a specific place on the page itself. You can scroll down to it. I can sort of place it down here, or just like before, I can add a PyTerminal element to the page, and the PyTerminal will be slotted in there when it appears, right? So I have 2 paragraphs now, then my PyTerminal, then my other 2 paragraphs, and so on. So all the previous behavior is still there. We've just changed the default to be this docked behavior just because we have found that's what users mostly want, is a text output for print statements, for troubleshooting, and so on, and not sort of an inline thing. But if you want it, it's still there under docked equals false. So that's the updates to the PyTerminal. They're very exciting. They look really good. I'm really excited about this. The other thing, and again, this is in the documentation. If you want to, so this xterm.js is a dumb output terminal, right? It's just enabled in output mode, but we do expose the internal xterm.js object, which has the ability to start accepting input handlers. So if you want to turn this into a full-fledged terminal to accept input and output, you can. We haven't just yet, but one can. We've exposed that API as well. Cool. Yeah, that's a fun feature as well. Let's talk about, what do we got to talk about? Let's talk about Pyodide and Pyodide 0.23.2 that we have brought in. So Pyodide, and I've mentioned a few times over the course of this, but for those who aren't familiar, Pyodide is the runtime. This is pyodide.org. Pyodide is the runtime that PyScript is largely built atop of, and obviously Micropython and other runtimes are coming. Pyodide is the primary one for now. Pyodide project, in 30 seconds, is 3 things: taking the CPython interpreter and compiling it to WebAssembly so it can run in the browser. It's a bunch of additional scientific computing libraries that are also take their C extensions and compile them to WebAssembly so they can run in the browser. So NumPy, SciPy, AstroPy, scikit-learn, bunch of other things. And then also this interactivity layer, this high wire layer, where you get JavaScript and Python interactivity in the browser as well, right? That's the Pyodide project. We've upgraded to the next Pyodide version, and that brings with it some cool new features. One of them, of course, is that Pyodide is now running on Python 3.11-2, as opposed to 3.10.6, I think the last release was, which is very exciting. So we get all the cool things that come with Python 3.11. We get better error messages that we've seen some of today, right? We've been seeing those nice little carrots in our error messages in the console. We get exception groups for handling nested exceptions. We get faster CPython improvements. There is a speed improvement in the latest version of Python. And because Pyodide literally is the CPython interpreter, any improvements in Python, Pyodide gets, and therefore PyScript gets. Very, very cool. Pyodide has also added and built a bunch of new Python packages for the web in the latest release. Fast Parquet is one I know users have been asking for handling Parquet data, which is a big data format for quickly loading the kind of data you want to put in a pandas data frame or something like that. You can do that directly in the web now and do data apps a little bit more easily. MyPy runs directly in the browser window now, so if you want to be doing that kind of code checking in your browser, you can. Like, if you want to run MyPy on the user's code that's in the REPL, totally possible. Pixel, the Pixel game engine, is now available in the browser. It's still a little bit experimental, but the Pixel engine, for those who haven't seen it, I will load it up here. This is just Google here we go. Just Google Pixel game engine. It's a retro engine, much like if you've played with like the Pico 8 is sort of the most famous one. Allows you making sort of retro 16-color 8-bit games. But written in pure Python, right? So a lot of the sort of retro engines require you to write in their own flavor of a language. Pixel is a Python API and a Python package. So today you can do pip install Pixel and start writing these games directly on your computer, or you can run your games in Pyodide and therefore in PyScript and write web games directly in Python that run serverless in the user's browser. Super, super cool. A little bit experimental. I have a previous blog post that I'll put in the description below that talks a little about the development process for these. And as this gets firmed up a little bit more, and a couple of the sort of slightly criminal things, no judgment, but slightly criminal things happening about how infinite loops work between Python and the CPython interpreter, as those get cleaned up and ready for release, well, you will surely be writing about this more, but a very exciting development there. So lots of cool new packages that have been added to Pyodide, which now, of course, PyScript has as well. And a bunch of other relatively minor but significant API changes. The one I want to mention for PyScript users is as follows. And I have a whole blog post on Pyodide's create proxy method. When you, how to explain this? If I have the JavaScript global namespace and I say, let's create a Python object. So let's make it just a real simple from data classes. Oh, here, let's just do a function. Def foo print foo. Right, so that's a Python. Foo is now a Python object that I've declared, and I can make it a JavaScript. I can make a JavaScript proxy of it by saying js.jfoo equals foo. So now in that context, let's load the chat onto the screen, which is exactly what I meant to do. Let's load this live. So now that we have this in place, let's add a button that on click runs our new jfoo function. And we'll give that button a label of foo. So just to reiterate, so what we're doing here is we're just defining a Python function. We are creating a creating a proxy of it on the JavaScript side that references that Python object. And then when I click this button, we should be able to call it, which pretty much just works. There are times and places where this kind of proxy creation fails, right? It can't determine whether you want to hold on to a reference to this object or not. And for this reason, Pyodide has a create proxy function. Which appears in a ton of early PyScript examples, mine and others in the documentation. And the only thing I want to do this whole tortured explanation for is that in Pyodide 0.22, the Python modules got rearranged. So now, rather than being able to do from Pyodide import create proxy, it's now under pyodide.ffi.create proxy. So this is all in service of like trying to help people take earlier PyScript and Pyodide examples and promote them into the future. You'll want to look up things like create proxy or 2JS for doing object conversion now live inside either the FFI module or the code module or things like that. Go look at the Pyodide documentation. It's all there. I just know we have a lot of early demos that say from Pyodide import create proxy, and those are now in the newest release are all broken because APIs change. So go look at the docs and you'll be fine. I just thought it would be worth mentioning here today. Speaking of looking at things on the web, I want to take a hot second to share with you a cool new project that I have put together recently. I'm a little self-bragging here. Cool new project that I did. But I think it's neat. So this is PyScript.recipes. This is live on the web right now. If you go to PyScript.recipes, and yes, it is under the .recipes top-level domain. PyScript.recipes is a repository for how to do things with PyScript and Pyodide. One of the things that I do in the PyScript community is, it's stuff like this. I answer questions, I help people solve problems, I tinker and try things, and there are a number of questions that I see a lot. Sort of fundamentals about how do I do X? How do I install PyScript? How do I load a JavaScript object in Python? How do I hook up an event listener and things like that? So PyScript.recipes is one more way that I am trying to get that information out into the community and reference all the most common questions that you might have. So if you, on the left-hand side here, if we see PyScript.recipes, how do I add a REPL to the page? How do I upload a file to the page and let it be processed by my Python code? How do I install Python packages into my PyScript page? I think there was a question maybe before we started, about how do we install Python packages or use micropyp. I think the specific question was, how do I use micropyp to install packages in Pyodide or PyScript? And the answer is on PyScript.recipes. We have a page for installing Python packages. You see we have answers for both PyScript and Pyodide wherever we possibly can. Sometimes they are identical, right, with PyScript mostly running on Pyodide. Sometimes the answer is just, well, you do the same thing either way. Here's the syntax. It's all pure Python code. But wherever they are different, like, for example, in the installation step, in Pyodide, you use a package called micropyp to install things. In PyScript, we put them in the pyconfig tag. You know, that sort of thing. So go check out PyScript.recipes. Hopefully it is helpful to you. I continue to add new recipes just about once a week. And if you're like, hey, there's something missing here, please come over to the GitHub repo for PyScript.recipes and leave me an issue or a pull request. Like, this is only sort of made better by people asking questions and saying like, hey, I don't know how to do this specific thing. And I will try and get the recipes up there. There's another way of trying to say, here's some fundamentals that you can learn from. So go check it out. So that's PyScript.recipes. It's sort of, I would say it's in late beta. Like, it's on the web. It's public. You can go see this now. It's continuing to get improved and updated and tweaked. And if you have questions or contributions, please do let me know. That would be a delight. Other cool things that are happening. Oh, other cool web things is a good transition. So PyScript has a new core team member, Andrea Giamarchi. My pronunciation is awful, but Andrea is incredible. He has been around the web for a very long time, working in web standards and accessibility and backends and polyfills. Python people, here's a word I didn't know before working on PyScript. A polyfill is taking a feature from a later browser's API and essentially backporting it for users to earlier browsers, right? If Chrome added if Chrome and Firefox added a feature in 2023 that's really useful and we want to use it for our web page, it might be useful to write basically a shim that does that same feature for earlier users of those browsers, assuming they don't have it yet. So Andrea's done a ton of work building polyfills for a whole bunch of web features. Awesome guy, super smart. He came out of the PyScript team. He's really a heavy hitter in the web stuff. We have a lot of Python people in the core maintainers group. And Andrea is a web guy. He's bringing a lot of effort there. And so one of the things that Andrea was doing as an experiment and now is getting promoted to a new thing is creating a technical preview for what we're calling PyScript Next. And this technical preview, tech demo, sneak peek, if you want to play with it, is online right now at pyscript.net/techpreview/pyscript.core. I'm sure there is a way I can put that on the screen so you don't have to like copy it out of me saying it here. I'll put this here. pyscript.net/techpreview/pyscript.core is the URL you want to go to. I should also put a link to that in the description down below. This is essentially a from-the-ground rewrite of what PyScript is doing to sort of run on the web. So not necessarily changing like the Python API, but like how do we get Pyodide loaded in the browser? How does it interact with existing script tags? How would we add additional functionality? And so all this functionality is things that Andrea has been working on to sort of build in a more web standards friendly way. The script type Py thing that I mentioned way back at the beginning of this is an example of ways that we on the PyScript team were doing things that worked but weren't the most web standard-ish. And Andrea's like, okay, well, I'm a web standards guy. The way I would build it is like so. So this is the results of his experiment, and we're going to be incorporating huge parts of this behind the scenes into the next, I believe the next release of PyScript is the goal. On the user end, we'll make sure that any changes in like the front-end API or the tags or something like that are documented and changed. I don't know that there will be that many changes to existing APIs based on this sort of ground level rewrite. What is happening is, I mean, a bunch of performance improvements, frankly. It'd be a little hard for me to do an apples to apples comparison because my PyScript version is running on my computer versus this sort of web demo, but the load time is like 40% faster just because Andrea's doing some clever things around loading. You can also see, like, you know, it's a tech demo, right? So it's currently running on the previous version of Pyodide because that's where we were when the demo got started. You know, this is not in any way a release. It's a sneak peek. But there's lots of cool stuff coming together in here, like Micropython. So this is Micropython, a build of Micropython running in the browser, counting up toward infinity. Micropython running in a worker thread experiment is going on here. things like experimenting with different PyScript environments. So like if you wanted to run Micropython and Pyodide based tags on the same page, how you might do that. What other things are in here? Continuance of APIs like Py events, like Py-event that we talked about earlier in Pyodide and Micropython runtimes, running code in a worker, passing input. There's so much good stuff in here, and this is a technical preview. It's very much a work in progress. It's not secret. Like, this is all happening on the public GitHub in a separate branch. It is very much like, just what Andrea is working on. So take it all with like a, hey, that's neat, but please don't start building things on top of this yet, because it all is going to change. One cool thing that I do want to say that I'm just very impressed by is once Andrea had this framework in place for like, we load Pyodide and we run code in it, essentially, we load Micropython and we run code in it. What other environments could we run code in? How about something like Ruby? So there is a build of the Ruby interpreter for Wasm and Wasi. So why don't we have like Ruby script that runs Ruby in the browser in the same framework? Or how about the Lua interpreter, which Wasmoon is one of the builds for that. Why don't we run some Lua in the browser in the same framework? It turns out that once you have this more generalized framework for executing code from a WebAssembly runtime in the browser, bringing in other WebAssembly runtimes is not that complicated. The work of building those runtimes could be incredibly complicated, right? Porting Lua to WebAssembly, non-trivial. All I'm saying is that the framework that we're building around those runtimes is much more flexible than the previous one. I don't know if that will necessarily be a fully released feature of PyScript as a concept, or if that's going somewhere else. It's just neat, right? That it just sort of just works that way. So that's the technical preview. Check out pyscript.net/tech-preview/pyscript.core for more features. This is all, this sort of goes to your question, Mojo, earlier about like, when is Micropython coming? It is running in the browser right now successfully. Part of it is like, how do we do, JS integration? How do we get there? But we're really quite close. Things like plugins, running code in workers, that's all coming down the pipe too. So go and play with this if you're excited about it. I am clearly excited about it. And we'll see which and how these things get incorporated, and how we'll document any changes that this leads to as they come down the pipe. I think, unless there are any other questions, there's only one more thing that I want to talk about, and that is PyCon 2023. So a bunch of the PyScript team, myself included, had the pleasure of going to PyCon 2023 in Salt Lake a couple months ago, and it was awesome. It was really, really incredible. It was my first PyCon, of all things. The PyScript team had a tutorial, which you can find on YouTube, and which is linked in the description below by the time you're watching this after the fact. And get to give 3 hours presentation on how PyScript works, how you can build things with PyScript, how the events API works, how does PyConfig work, and all these things. We got some really great and amazing feedback from that event as to how people wanted to use it to build things for their own projects. There were several other talks on PyScript as well. Fabio Plieger, the principal engineer, gave a talk on the magic of PyScript. Nicholas and Paul Everett gave a talk on how you might go about building your own PyScript, thinking about the layers of abstraction that wrap a WebAssembly interpreter in the browser. Antonio Cuny gave a talk on WebAssembly, and it gives, if you've been hearing me say WebAssembly and you're like, what the heck is that? Go check out Antonio's talk from PyCon this year, PyCon 2023. And he explains, at a low level, what is WebAssembly? What is this, weird new assembly-like stack language for the browser? And why do we care? And what is it good for? Really super cool. I didn't get to stay for any of the sprints, but I know some amazing work happened there. We had a whole flood of contributions that came out of the sprints, and which is really awesome. We have a couple new contributors who have really stuck around or doing some great new things on PyScript. If you are interested in contributing to PyScript, I would say it is an open source project. Everything exists on GitHub at PyScript/PyScript, and we really welcome PRs and issues and anything else in discussions. We have a discussions tab. If you're afraid of saying like, I don't know, is this an issue? Is this a feature request? Does it fit? Discussions is a great place for any of that general content. We'd love to see. As a point of fact, PyScript is sponsored by, run through Anaconda, right? I'm not an Anaconda staff member. I'm just a guy who saw PyScript, thought it was the coolest thing ever, and just had to get involved. And now here I am. I get to, be on the maintainers list and contribute in whatever way I want to, including making these demos. So really do come join the team. It's a really welcoming and amazing group. And I've been so lucky to get to work with some of the cool people over on the Anaconda side, making this cool PyScript thing. So please do contribute and come let us know what you're building, how you're building it, and what you want to see next. We also have a Discord, which is linked in the description as well. Discord is great for, hey, I have this quick question, or hey, I made this cool thing, you should check it out. Really nifty community over there, and we'd love to see you as a part of it. I think that is it for the What's New in PyScript 2023 05.1. Thanks for sticking around for these last hour and 40 minutes. Thanks for bearing with us. A couple of the live demos went great, and a couple of the live demos went a little off the wall, which is sort of the point of live demos. And keep your eyes peeled for what's happening in PyScript next. Like I say, this overhaul is massive and really cool, and it's bringing some really great new opportunities for improved functionality, improved speed, improved flexibility. So we're really stoked to see what comes out of it next. If you build something small or large, if you build a hello world page, if you build the next React with PyScript, we want to see it. We want to see it on the Discord. We want to see it in the forum, wherever you want to post it. We want to know how people are interested in using this stuff so that we make sure that PyScript is shaped for what you want to do. So reach out, come be involved. And, until next time, when we're releasing the next PyScript. When is the next release? I have no idea. We will see it all together as those features come together. But until then, I've been Jeff Glass. Check out the links below. Check out the blog post link below for all this detail in writing if listening to an hour and 40 minutes was just too much. And I will catch you on the next one. Have a great day, y'all. I don't know what happened with this live split thing. I'm gonna turn it off here too. If you're watching after the fact, this is your Easter egg. I use live split to do those tabs in the bottom of the screen, and something about them broke, so now they're gone here too. Have a good one.